let's talk a little bit about Boolean arithmetics. And by Boolean arithmetics, I mean let's talk about using the values true and false as their integer values. So as you can see, true and false are Boolean values, but they can be converted to integers with the int built in. And not only that, you can use them implicitly as numbers when needed. For example, if you do something like true times false, that's equivalent to doing 1 times 0, and so that obviously evaluates to 0. Or for example, true plus false, that's going to be 1. True plus true is going to be 2. Now, why is this relevant? Because there are cases in which using this can make sense. For example, imagine you have let's say a list of numbers, and let's make them the first 10 non-negative numbers. So you have a list of numbers, and now you want to count how many of these are, say, divisible by 4. How can you do that? For example, if you use a list comprehension, you can keep all of the ones that are divisible by 4. So how do you do that? There's going to be each number for the number in the list of nums if the remainder when divided by 4 is 0. Or if there's not a remainder when you divide by 4. So these are the divisors of, the numbers that are divisible by 4. And now obviously you can use the length to compute this. But imagine that that nums was a very large list and that there are plenty of numbers that are divisible by 4. This means you have to build a second very large list and then compute its length. If you use generator expressions, then this is lazy, but now you cannot compute the length of the generator expression, and so what you can do is you use the built-in sum. So now what you're doing is you are summing, I jumped there. So you cannot compute the length of the generator expression because this thing here is lazy. So I'll show it to you. Wait, that's not the one, this one. So this one is lazy. It's a generator object. Now what you can do is you can use the sum to add all these results. So instead of filtering, what you're going to do is you're going to sum something. What are you summing? Well, not num modulo 4 for num in nums. Now what this is doing is it's going through the list of numbers. This goes through the list of numbers and then it computes if there is not a remainder. And the sum ends up counting those numbers. Because this thing, if we do this as a list comprehension, is just going to be a bunch of Boolean values. True, false, 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 true, false, 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 true, false. And by using the sum built in, we add all of those up and we get 3. Why? Because there were 1, 2, 3 instances of true in the original result. And this is one case where using Boolean arithmetics can be useful.